Before we begin this example, we can just take a quick review of the definition of the derivative using the limit notation. You have two different versions you can use here. We'll go with option 1, which is f prime of a equals the limit as x goes to a, and we have the function f of x minus f of a in our numerator, and then we have x minus a in our denominator. So that's one option that we can use. The second option that we could use is f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a in the numerator and h in that denominator. So let's go ahead and take a look at our first example here. We're going to be working with the function f of x equals 3 minus 4x, and we're going to be looking at an a value of 2. And part A in this example says to find the slope of the tangent line, which is going to be f prime of a. So let's go ahead and use our first option there. F prime of a is going to be equal to the limit as x goes to a of f of x minus f of a in our numerator and x minus a in our denominator. So let's go ahead and plug in the components that we know. We're going to be looking at an a value of 2. So we want to be calculating f prime of 2. And when you rewrite this, make sure that you keep your limit notation. X is coming towards 2 in this case. We're going to replace this f of x function with our function itself, which in this case is 3 minus 4x. And we need to subtract out f of a. So let's actually go ahead and calculate that real quick. In our case, we're going to be finding f of 2, since that's our a value. And you want to go ahead and plug it into the function. Right? We have the function 3 minus 4x. So we'll plug in the value of 2 for x. 3 minus 4 times 2. This is going to give us 3 minus 8, which will be negative 5. Right, so we're going to replace f of a with a negative 5. Now be careful here, because this subtraction sign is this one. Okay, I'm replacing f of a with my negative 5. And then in our denominator, we will have x minus 2. And now let's go ahead and simplify what we have. This is going to be the limit as x goes to 2. In our numerator, we've got 3 minus 4x plus 5. And in our denominator, we have x minus 2. And let's go ahead and combine like terms here. Right? We can combine the 3 and the 5. Again, make sure you're carrying your limit notation throughout this problem. 3 plus 5 is going to give us 8. So we'll have 8 minus 4x in our numerator and x minus 2 in our denominator. And we can go ahead and factor the numerator. Notice that they each have a common factor of 4. So let's go ahead and take the 4 out. That's going to leave us with 2 minus x. And in our denominator, we'll have x minus 2. Right, now notice you can't cancel anything quite yet. Right, you have a 2 minus x in that numerator and an x minus 2 in the denominator. They don't quite read exactly the same. We could take the negative 1 out of that factor in our numerator as well. Right, so I'm going to go ahead and factor out that negative 1. So that 4 I'm going to factor out the negative 1 from this 2 minus x. And keep in mind, if I factor out that negative 1, that means I'm taking each of these terms and I'll be dividing it by negative 1. So 2 divided by negative 1 is going to give me a negative 2, and negative x divided by that negative 1 will give me a positive x. And notice that's helpful in this case, right? I can rewrite that. This 4 times negative 1 will obviously be a negative 4. And I have negative 2 plus x. That could be rewritten as x minus 2. Which is what I need, since that's what we had in the denominator. And now these factors can cancel, right? As long as you have the same thing top and bottom, and they're connected by multiplication, right, you can go ahead and divide those out. They'll divide out to give you a 1. There's nothing else here for me to plug in. So this limit as x goes to 2 is going to be negative 4. Let's go ahead and take a look at part B. Right, we still have our information from what we found in part A. Right, remember that f prime of 2 turned out to be negative 4. Right, so if we're looking at part B, we want to find the equation of the tangent line to f at x equals 2. So if we're finding the equation of this tangent line, we're going to use our point-slope formula. So recall that that was y minus y1 equals m times x minus x1. Right, now this x1, y1 is going to be a point on our function that we're looking at. Right, we're looking at an a value of 2, and we actually have a point. Right, we know that f of 2 was equal to negative 5 when we did part A. Right, so this would be the point 2, negative 5 on our graph. Right, and so you do have an x value and a y value that you can plug in to this function. The m in this case is the slope of that tangent line, which is what we found in part A, right? That's the one that came out to be a negative 4. So let's go ahead and plug in each of our components here. The only ones we'll be plugging in for are the y1, the x1, and the m. Everything else is going to stay. So we've got y minus, our y1 value here is a negative 5. Our slope was negative 4, that was from part A. And we have x minus 2. And let's go ahead and simplify this. We'll get y plus 5. I'm going to go ahead and distribute this out. This would be a negative 4x plus 8. And let's go ahead and subtract this 5 from both sides to get our equation. We've got y equals negative 4x plus 3. Alright, we'll leave that in y equals mx plus p4. So that would be our equation of the tangent line at x equals 2.